This question has several subparts, all to do with a gaseous equilibrium occurring in a closed system. A closed system is one where matter cannot enter or escape because the vessel is sealed, but energy can move to and from the system. This is the reaction at equilibrium. First, we need to give a definition for the phrase chemical equilibrium. A chemical equilibrium is a state in a reversible reaction where the rates of the forward and reverse reactions are equal. The graph shows how the concentrations of the three species at equilibrium in the reaction change when certain reaction conditions are altered. Now, Le Chatelier's principle governs and explains what happens to an equilibrium when a condition is changed. It says that if a chemical system that is at equilibrium experiences a change in concentration, temperature, or pressure, the equilibrium will shift in the direction that reduces the effect of that change, and a new equilibrium will be established. So we are told that oxygen gas is added to the vessel. We need to identify which species, 1, 2, or 3, represents the oxygen reactant. So we need to look at what is happening here on the graph. Notice that when oxygen gas is added, reactant 1 immediately increases in concentration, and we can see this from the short vertical line. Since oxygen was added, and this species concentration immediately goes up, this species, species 1, must be oxygen. So oxygen gas is represented by 1. The next change which occurs is a change in volume of the container. Did the volume increase or decrease? Notice that when this change occurred, the concentrations of all three species immediately decreased. This tells us that the volume of the vessel was increased. Now we are asked for the corresponding pressure change. An increase in gas volume corresponds with a decrease in gas pressure. And we can give this explanation we just discussed for the next question. Next, we need to identify compound 3. One way to do this is to look at what happens to the concentrations of the three substances when oxygen is added. We said that when oxygen is added, the concentration of substance 1, which is oxygen, increases immediately. And then it starts to decrease, which means it is being used up. Notice that at the same time, the concentration of substance 3 decreases too. Since oxygen gas is a reactant, then substance 3 must also be a reactant, namely carbon monoxide. And at the same time, the concentration of substance 2 increases, so it must be the product carbon dioxide, whose concentration goes up as the reactants combine together to form it in the forward reaction. We can use the explanation we just discussed for the next question, or we could explain it using Le Chatelier's principle in more depth. We would then say, when more oxygen is added, the equilibrium will shift to the right to decrease the concentration of oxygen, and so the forward reaction is favored. And this will cause the concentrations of the two reactants to decrease, and the concentration of the product to increase. The next change which occurs is a temperature change. We need to identify if the temperature went up or down. If we have a look at the reaction given to us, we can see that the enthalpy change is negative, and so the forward reaction must be exothermic, and therefore the reverse reaction must be endothermic. Exothermic reactions are energy releasing and so are favored by cooling, while endothermic reactions are energy absorbing and so are favored by heating. We can see that the concentration of oxygen gas starts to decrease when the temperature is changed. And so does the concentration of carbon monoxide, while the concentration of carbon dioxide increases. This tells us that the forward reaction is being favored by the temperature change, and that the equilibrium is shifting to the right. If the forward reaction is favored, the system must be being cooled, and so the temperature has decreased. This explanation we just discussed will help us answer the last question.